good. So let's start with the kind of like Q&A. I think the use case here is very obvious, right? So basically, you can like Langchain Q&A of your documents. This enables you, right, to ask natural language questions about your own documents, okay, and then get intelligent answers extracted from that content, okay? Because you know the LLM models, they are really good. They are like pre-trained, but they are not taking into account the context unless you basically tell it to do it, okay? So we're gonna look into some of the capabilities of that. Of course, right? Nowadays, tools like ChatGPT or Claude also allow you to, you know, to upload your documents and then to ask questions to the documents. Potentially, you used it for like, I don't know, preparation for exams, things like that, right? But I mean, you would only upload documents that you feel okay, they are not important to you, that they are they are not somehow like so private that you want to share it like basically with the world. As you know, ChatGPT and Claude from Anthropic, etc., Grok. If you're using their chat product, they write basically in their disclaimers that they're gonna use the information for further refining the models, right? So for training purposes, right? So I'm not sure that you should upload your personal tax account statement up there or any important contracts up there. And for sure, if you are a company that sits on, sits on private, let's say, information, right, or proprietary information that is important, you don't want to upload your patent documents or things like that to the LLM chat interface. Okay, you want to keep it. Safe. You want to keep it local, and then the only way that you can chat with your documents is by basically hard coding these capabilities and then attaching it either to to an API, right, like we did. Whereas the companies say when you access them through the API, they won't use your documents for training purposes. But then but then there's still, let's say, a little bit of uncertainty whether that's truly the case. At least in particular with a lot of Chinese companies, you probably heard, there even the recommendation is that you shouldn't like even like using the API, you shouldn't share important documents information through that through that API. And in this situation, right, then would be even better to maybe also use just a local model that you install and then you run on a local server. So right, the main argument of those that say, okay, but those companies, they are not able, I mean, it wouldn't make sense for them to use your information, because if this basically becomes public, then they gonna lose their credibility, right? So they say, okay, if companies like Microsoft or OpenAI or Google, right? I mean, they are built on trust, and so they have to stick to that. Okay, but still, I mean, you don't know, right? There's a lot of political turmoil out there. A lot of things are changing in the world. So still, maybe for some things, you want to, at least like we should talk about it, right? At least we should talk about it. Are we willing to live with that risk or not, right? But for sure, never use the regular chat interface, because there it's for sure they're going to use this information, right? And there, I don't know if you've seen this, but there are a lot of YouTubes created on kind of like hacks of how you can get out of the chat interface information from conversations that other users had with the chat model, right? So there are like hacks where you can find out, okay, yeah, Lika, like what did she discuss actually throughout the year with ChatGPT? Okay, so be careful with that, right? So there are, I mean, of course, it's always a little bit kind of like a race, right? Like in terms of course, then this, you know, becomes public, and then they're going to fix it, and then they find for another way to kind of like get that information out. But there was all kinds of information, like even like, let's say, API keys that they were able, like from other people, they were able to get out API keys that actually function and all of that stuff. And this is because people load in their API keys into this chat kind of like interface. Okay, great. Well, yeah, but basically let's get started with this with, you know, using Langchain a little bit to Q&A over the documents, right? I think you discussed it's 1,536. Okay, so basically you've got, like, if you take a chunk of text, for example, and then basically out of the text there will be you know, vector of you know, of numerical numbers. I mean, maybe this looks better, I think. Yeah, like this, right? So out of the data, like, could be like, you know, your text, your legal documents, or like you know, paragraphs out of your text, right? And the system is going to be creating 1,536 numbers representing your text. Okay. And then this will be then stored to a vector database, right? And then when the user input, so to speak, comes into play, okay, then basically it will compare. So it will transform the user input into embeddings, okay, and then it will look into the vector database and see whether there is anything stored that is similar to the user you know, input. And then what is basically most like similar is then going to be it's you know, it's then going to be taken as the context for the basically for the response, right?
Right.
Okay, so this is basically what is like kind of like going on under the hood. Of course, when you like think about it a little bit, I know you worked with it a lot, but basically when you have this one here, you can create basically, so it's always going to be 1,536 you know, numbers. For example, for OpenAI, if you use the OpenAI way to create those kind of like embeddings. You can vary the size, however. You can make it, I think there's also like half of it, like 700, you know, 68 or something, kind of like smaller vector that you can create, and you can push it up to 3,800 roundabout. But the decision is based on how you create those embeddings, because you could decide, okay, I'll create an embedding for the entire document, or I create an embedding for an entire paragraph or for a sentence, right? And so based upon how you decide to create the vectors, then you have, let's say a more granular versus less granular, let's say vector storage database, okay, from which you can then compare to the user inputs, okay? And this is a little bit, also kind of like trial and error, and depending on the specific use case that you're dealing with. But this is also something, that where there is no, let's say, best practice solution yet, but it really depends on on the use case, yeah? But this is something kind of like to keep, to keep in mind. Okay, so let's see what we're going to import. We're going to import the retrieval, QA library, then OpenAI, then, okay, we need CSV loader, doc array in memory search, and then we also, we gonna initialize the OpenAI embeddings library, basically to create the embeddings, and then, okay, to display basically the, the Python code kind of like markdown. We're going to import this as well. Yeah, so basically, okay, like retrieval Q&A, basically what it does, it's the main chain, right, that combines the document retrieval with question answering. Okay, so basically it takes the user question, it finds the relevant documents, and then generates the answers. Yeah. And then we have, like with respect to, the doc array and memory search. we need this one for so like to basically to store the embeddings not in a database but in memory. Okay, just to make things efficient for the example here, and not to be so that we don't need to also set up a backend where we basically store this information. So we're going to store the embeddings in memory through this through this library, or basically component of kind of like Langchain. And then this is the also the important one that I talked about. So this basically library then helps us to convert the text chunks into vector embeddings, okay, using the OpenAI embedding models. And that's, I think, basically the most important components that we kind of like need here. Okay, so we're going to load our API key. Then we're going to initialize all of these libraries, and then we have this data set here. So it's again this kind of like this it's a data set on product names and descriptions. Okay, good. Kind of like Q&As, right? We can look at it a little bit. Let's see, maybe make this bigger. Why is it not showing the left-hand side? Let's see. Have questions, reach out. Okay, so basically, yeah, information about those products. Okay, let's put it like this. So we're going to load this CSV file, and yeah, and then from the indexes, we're gonna import our vector store index creator. Okay, and basically, what this does is like a high level utility class. Okay, that will help us basically to index the documents, or basically the file, okay, later on. Good. So here now we create the embeddings function by calling OpenAI embeddings, and then here we're going to create the index, where basically we use the vector index creator, right? Which basically what it does, right? So it loads the document, okay? It splits it into chunks, then creates the embeddings, and then it's gonna store it, okay? Store it in memory, because here we basically specified that it should be stored in memory. But basically, this is a function, this vector store index creator, that does all of that. One could do this manually. Load it, split it, and do the embedding. But here it's basically done automatically. But keep in mind, right? So, like at times, as I said, depending on the use case, you might decide upon how you specifically want to split up the document to create those embeddings. Good. So we load that, and now, okay, now we create the query. And which is as follows. So please list all your shirts with sun protection in a table in Markdown and summarize each one. Okay, so once again, we have clothing products. Okay, so these are the names of the products, and here there are descriptions of the products. And so there are many descriptions, right? There's a total of 1,000, okay, product descriptions. And now we want to talk to the documents, and we want to basically query, okay, for whether some of those clothes have sun protection built in, because as you know, there are clothes that have that feature, right? It's usually used a lot, kind of like for kids, okay. So basically our kids used to have that a lot, right? Wearing like clothing with sun protection in the summer, particularly when you're hanging out at the pool or things like that. And so basically we want now this basically the LLM to go through our product descriptions and then look out for, okay, is there any, let's say, embedding that is close to the embedding that would be created when we convert the sentence into an embedding. So basically it's all about, is there anything mentioned about sun protection, etc. Okay, great. So let's run it. It'll take a little bit of time, maybe. Let's see. And now we can display it in a markdown with a nicely structured table, and we can see, okay, all right. So the LLM has been able, okay, to find 4 product names, okay, and thereby, you know, extract kind of like their sun protection class, as you know, as you might say, the you know, kind of like UPF rating, okay, 50 plus, okay, sun, kind of like sun protection, and it also creates kind of like the key features of those. Also with the development of the LLM models, that they become just, you know, much, I mean, the responses become more and more sophisticated, okay? Yeah, but maybe the idea is maybe we don't, as said, we don't, let's say, necessarily kind of like, you know, need it, right? But then maybe we can you know, potentially use a less let's say sophisticated model, right?
Right.
So yeah, but basically, I mean, if we could show you like the real, maybe it's structured like this better, but basically, yeah, it's only these 2 columns here, okay, and then the description, okay, it's I mean, it's done a little bit, let's say, structured, right? So it's a description, a size and fit, specs, construction, and then questions. So maybe because of that, it says,
okay, yeah, that's why.
it has kind of like adapted, let's say, this relatively structured way of you know, of those product descriptions. Yeah. Good, yeah, but I mean, the good thing is, okay, now it's only running through, I mean, it's only running through the API, and so it shouldn't use this information. Maybe we don't want to share the details of our products with basically with the world through through ChatGPT or so, and so, or maybe we even want to use a local model, but basically it can be set up relatively quickly. It even runs without a database, right? So it's in memory. So I think it's a nice, comfortable way to kind of like do that. Okay, good. Let's see now. Yeah, let's basically kind of like continue. Now we're going to load. Yeah, now we're going to load, you know, basically those reviews. I'm going to show it once again. Did I close it? Yeah, close it. Yeah. Oh, okay. Yeah. So basically, as you can say, I mean, this is like a CSV file, and as you can see, each product is you know, is put into sorry, one row. And so now basically we just load the first product description. So basically, as you can see here, if we use the CSV you know, loader, and then we basically load the CSV file and put it into docs, then we can basically query from the source CSV file the specific row, and then we get kind of like the page content. Okay, so now we got only selected the, you know, first let's say the first product. Okay. Good. Now again, let's basically from Langchain again import the OpenAI embeddings you know, creator here, and now let's create an embeddings query which says, okay, hi, my name is Harrison, just to show you basically what is going on, and then like under the hood, when you basically create those embeddings, and now you can see, okay, when I mean, I took this sentence, okay, hi, my name is like Harris, I don't know, and I can just, and I live in Washington, okay, doesn't matter, but if I run that, it's always going to be creating 1,500 36 numbers to represent the sentence. Yeah, and even if I go, you know, down as much as like I mean, down as much as like a word, even. Okay, so like this, it's always going to be 1,536. Okay, no matter how long or short the text is. Yeah, yeah. So you, yeah, but I mean, this is important to keep in mind, because then really it does matter how you chunk up your documents, right? Because you can, like, of course, I mean, probably 1,536, like it can probably, you can put in like a 5-page, 10-page documents in there easily, and you have a good representation of the document. Okay.
Okay.
But still, it's, you know, would be different if you chunk the document up into, let's say, I don't know, these 5 pages or let's say, I don't know, like, yeah, let's say like 5 pages. You could also chunk it up into, I don't know, it's subcomponents. Maybe it's like chapters inside the document. So you could use it like on a chapter level, or even on a sentence level then. Okay. So it depends really on the document. Maybe if it's a legal document, you want to make it on like a, I don't know, like a sentence level or a paragraph level or something, right? Maybe if it's like a big product description, maybe it's fine to just turn the entire document into one embedding. You know, but this is something just to be aware of. Okay, that is really, it's always creating this vector, and you decide: is it one word? Is it one sentence, a paragraph, or is it I don't know? It's or is it a very, very large file? Yeah.
Okay.
Good. Okay. Good. Yeah. So now we're going to, you know, we're going to use basically this embedding that we have created. Okay. And then we are going to take it. Yeah, it takes a little bit basically. Yeah, then we do a, you know, yeah, so we basically load in a new query, put it like this, right? So we're gonna do a similarity search here. So we're now looking for, now we're asking for, please suggest a shirt with sun blocking. So it's basically it's similar to the question before, and now we can do here a similarity search, which will basically, it will take our query and then it will convert the query as basically as we done here with the hi, my name is Harrison, into this you know, 1,536 embeddings, and then it will compare the query against you know, all the stored documents in the vector, and then it will provide us with the information. Okay, how many documents did you find? And then we can basically show yeah, we can basically show that it did find, kind of like the first one here was the sun shield shirt. Okay. Right, that we've basically found, right? So it's created a new list, right? So basically it's now only storing within the docs only those which were similar to what we were looking for, right? So similar to our basically chunks here. Okay, good. Okay, what else do we want to do? Let's now just, you know, try out a little bit, you know, again, talking to those documents. So let's do kind of like the following call. Okay, so please list all your shirts with sun protection in a table in Markdown and summarize each one. Yeah, so basically kind of like a very, like, you know, again, a structured way of basically representing our findings. But yeah, pretty much we did so to speak achieve it before, but yeah, now it's basically, it comes out as Markdown, and so you can, okay, now in the Jupyter Notebook it's not shown nicely, but as you know, in the Markdown format, when you render it, it actually does become a nice table, right? Okay, what else do I have? Basically, there's there's a last query here that, so to speak, it uses a specific chain type method. It's basically, it's called the stuff method, and basically this is a strategy for handling multiple retrieved documents. So basically what this stuff method does, it takes all retrieved documents and stuffs them into one single prompt. Okay, so when do we need it? Basically when we want to keep things simple and fast. And when the LMN should basically should see all the relevant context at once. Okay, so I think basically it's a very generic, like, fine model basically to use, right? So you have many documents, and then you want to kind of like make the LLM aware of all of that at once, and then you would use this this join method, this stuff method. Sorry, and then of course it's if you're dealing with, however, many long documents here, you might exceed your token limits, produce a lot of costs, etc. So yeah, so maybe there it would be smarter, and I think we talked about this a little bit yesterday with respect to the change. So maybe you want to somehow iteratively basically refine the answer with each document, right? Maybe you want to go through more general document first and then refine the answer by using that in the later chain, let's say, the more specific documents, right? So this might make sense also for, like, product descriptions. Maybe there's some general product description first, and then you go into the details of the products, and this is basically how you can then build it up. That would be the kind of like the alternative method. So would be then kind of like refine, like kind of like define, like it's called the refine method. And there's also a map reduce method that can also be used, right? It's going to be like this, map reduce method. And basically what this does, it summarizes each of the documents individually and then combines it. Basically creates a summary out of the summary, so to speak. Okay, but we're gonna just use the stuff methods. So like this. Okay, and then please again list all the shirts with sun protection table in Markdown and then summarize each one. Okay, so this is just to show you, or just to talk a little bit with you about that. You can also specify here how, let's say, the similarities, search is going to be done. Okay, and then we get kind of like similar output to the one that we had before. Okay, so let us continue now with, let's say, evaluation of basically of what our model is basically doing. And so yeah, so we want to cover here three approaches. So the first one is how to create test cases, first of all, let's say manually, and then also automatically using an LLM generated example. And then the automatic basically way we're going to do this is going to be through a Q&A generate chain, let's say, function, which will then automatically create question answer pairs kind of like for us. And then we're going to talk about, okay, how we can first of all manually evaluate what was created, and then how we can do this in an LLM assisted way. Okay, so again, let's load our variables, and then basically I'm just repeating the steps from before. Let's see, let me just make sure that everything is gone here. Let's start it once again. Okay, I'm gonna use the same, the same file. Oh, I think this comment didn't run. Okay, now it works. We're gonna use the same file. We're gonna again use the doc array memory kind of like search to store the embeddings. In memory, we use the OpenAI way to create those embeddings, or style. And yeah, as a chain type, we're gonna use the stuff. And then we're gonna look into some data points here. Okay, so we just basically pick, I don't know, just random product descriptions. Number 10, cozy comfort pullover set, and number 11 as the ultra lofty 850 stretch down hooded jacket. So a jacket and a pullover set. Okay, now let's look into some hard-coded examples. Okay. So this could be coming from, I don't know, an existing website of your company, of your products, where, you know, already people sat down and they've created these, you know, most important questions that a customer might ask, okay, together with the responses, okay? And so if you have something in your company, you can basically rely upon that. You can take this, and here we're also using just made up kind of like queries. One is, okay, do the cozy comfort pullover set, does it have side pockets or not? Then the answer here is yes. And then what collection is the ultra lofty 850 stretch down hooded jacket from? And then it's called the down tech collection. Okay, it's written here. You can see it here in the description. It says, okay, this technical stretch down jacket from our down tech collection. This is where it's basically from. Okay, so you know, this is how you can build upon what you have. Okay, many companies have that on their product sides, and a lot of, you know, human labor work went into that. So it definitely makes sense to kind of like use this. Now, this would be a hard-coded example. So let's now try to create an LLM generated example. Okay, and there is, again, a specific, you know, library for that. It's called the Q&A generate chain. Okay, so specifically designed to kind of like create, you know, create or generate question answer pairs from the documents. Okay, so I think it's interesting that it's basically, you know, it's this, but basically it's automatically trying to generate relevant questions and answers based upon the source document you have. Okay, so our source document, it's still this product name and description kind of like CSV file. Okay, we're going to call it kind of like example generate chain. And then we're going to, yeah, we're going to create the examples, and we're going to look into, yeah, one of the examples that was created. This is the following. What is the approximate weight of the woman's campsite Oxford pair? Okay, so it's basically, it's running through, you know, it's running through the documents, at least through the first, let's say, 6 documents, and then it does create examples for that. Okay, and if we call the data for that, yeah, it's really it's done so correctly. So the underlying data from which on which it is created, this Q&A pair, is the following. It's really the woman's campsite Oxford's product. So it's actually then also creating the question, okay, what is the approximate weight of this campsite Oxford's basically per pair, and then it provides the answer to it. And let's see whether it has the answer from the description. Yes, and it's here we can see weight, and it's the weight that basically was extracted from here. So, right, so we can, you know, it was created kind of like automatically through that LLM chain, and we as a, you know, programmer, we can take a look and then basically manually evaluate, okay, was it good or not? Yeah, but basically, is it correct or not? Yeah, maybe I've experienced a little bit of a, let's say, you know, issue with that, like with that answer so far. I haven't yet resolved it basically, but as you can see here, the way the examples were formulated is query and then answer, okay, in a dictionary. But here I do get basically this Q&A pairs in front of that, right? I didn't have that, you know, I didn't tackle this yet, you know, to basically to get this out, right? Would be nice to have the similar structure. So basically just the, you know, the inner curved circle in here, but it did create the Q&A pairs as an output, and then inside is the query and answer basically. But I will, I later on kind of like combine it into the same structure, but just that you know, okay? And combine the examples, the manually coded examples, and the new example that was kind of like that was kind of like generated. Okay, good. Now, coming about, going about, once again, manual evaluation versus LLM assisted evaluation. So basically, here are our questions. Does do we have the side pockets? So basically this, this one example. So we can look into, okay, this was basically the question. This was the context given. Then we can see the prompt that was used. Okay, use the following pieces of context to answer the user's question. If you don't know the answer, just say that you don't know. Don't try to make an answer up, right? So there's a little bit of a safeguarding in here as a prompt at least. And then there is basically the name and the information. And so basically then this, the chain goes through here. We can basically see that. And how much we also get kind of like information on how many tokens have been used in total, kind of like etc. Right? So basically, if we do the, if we put the Langchain debug mode on and we run the query, we get the entire, let's say, under the hood, what is going on information, and then we can manually assess it and try to, I don't know, improve it, make it better, change the system prompt or whatever, right? This would be kind of like how we would do the, the manual evaluation. So basically by switching on the debug mode, okay, and then just looking through all of this, let's say conversation with the LLM. Okay, so maybe that's fine if you have that. If you're just dealing with, I don't know, with maybe very specific queries and maybe not so many. But of course, if you have a lot of products and you want to create a lot of, let's say, Q&A information for the customers, and you also have not a big team, so you don't have the time kind of like to evaluate all of that by yourself. You can do this in an LLM assisted way. So I'm gonna show you how now. Okay, this code basically this basically just fixes that we have this query in front of the automatically generated like Q&A pair. And then here basically through apply, we're going to run the create the examples. Okay, and now we're going to import the Q&A evaluator chain, which is specifically for looking into basically like a second LLM running through what is basically the question, what is the context, what was created as an answer, and is this really basically making kind of like sense or not? Okay. And so if we initialize that and then run it, okay, the examples, and together with the predictions was basically we ran through the through the examples and then generated the basically the questions. Now here we can see through this query here, like basically through this loop. Okay, we see what was the example. Okay, example 1 was first. I mean, it's still the old example. I mean, this is the first input was basically our first example, where it says side pockets. The real answer was yes. Okay, and now the predicted answer that was generated by the LLM was yes. The cozy comfort pullover set has side pockets on the pull-on pants. Okay, and now the predicted grade is then basically comparing the real answer and the predicted answer. Okay. And this goes on with also with the second example. The second was also manually coded, right? The answer was this down collection. The predicted answer was a little bit longer sentence, but still includes the down tag collection. And they mentioned here, so it's also predicted here. And basically, now we come to the other examples that were basically evaluated by the LLM. So by this, let's say, we can call it an AI judge, right? That basically compares the predicted answer against the expected ground truth answer and then grades them. Yeah. So the real answer is the approximate weight of the woman's campsite was. This was also generated by the LLM. And then the predicted answer is the same because it's basically, kind of like it did create the same, like really exactly the same kind of like answer. So that basically it is kind of like correct. But let's move maybe to a third one. What are the dimensions of the small medium size? The small size is basically this. Predicted answer is the information here. That the dimensions are the following. So I've got the dimensions in here, and then again, predicted grade, it is kind of like correct, okay? So, okay, like in a nutshell, right, what this does, like through this Q&A evaluator chain, you can set up an evaluator, okay? You can, now here, again, talking about the temperature leaker, low temperature would be like consistent grading. So here we actually want to make it low to be really kind of like consistent. And then we're going to evaluate the predictions. As we can see here, right? So basically the input is the fixed examples and then the predictions that were generated, and then basically it runs against, as an additional check, it runs it against your queries and then sees whether it's correct. Okay, so maybe, I don't know, I can see maybe it's like specific use for that. Maybe you want to be a little bit creative in your Q&A answer generation scheme, right? That there are maybe some out-of-the-box questions that users might ask, and you create them, but then you are unsure about whether they are true or not. And then this system helps you to then, with this low temperature, like the second, LLM model goes over it, or maybe let's say it could be like, the one is maybe a different model. Maybe it's not OpenAI, it's another model that's better on reasoning or whatever, and then predicts grades whether it's likely to be correct or not. Yeah. Basically out of the box, right? You don't need to build it by yourself, but basically this Q&A evaluate chain, basically it's out of the box ready to do this for us. Yeah. Okay, perfect. This was about the evaluation. So we move on to the agents, the last one.
Nice.
And so basically, I think this is probably the most hyped, right? One in the kind of like developer, kind of like community, talking about these agents, giving them more and more power and autonomy. And I think maybe you heard about it, but basically you can give the agents the opportunity to control your browser, and then it can go on websites and click on things and then make screenshots and download like agent. Okay, but let's here first load our, again, instrumental variables, and then we're gonna install here Wikipedia here at first. And then maybe stop the kernel real quick here. Yeah, I'm gonna load this. Wikipedia I've installed, and then Langchain experimental. And now we are going to install the following libraries. Here, create Python agent, load tools we need, also the function to initialize the agent, agent type we need, and then also Python Rapid tool, basically, to also being able to, you know, to call functions. But let's maybe just keep it simple here, I thought. So let's load the tool. Let's load the Wikipedia tool. As an LLM model, we use the 4.1 model once again. And then basically this here is the comment of how we are going to set up our agent. Okay. So basically, yeah, what this creates, it initializes an agent, okay, that that has, you know, specific that is able to use specific tools. I mean, we called the tools here. We can specify more tools, right? We could specify web query search tool, or they used to, yeah, or like a math, like calculator tool, or basically anything what is out there, anything that someone has been able to basically develop, or like you know, a coding tool, etc. Basically, we're going to specify it here, and then we give the LLM, so to speak, the opportunity to, yeah, to call functions. Okay, it can also be database queries or things like that. Yeah. Okay, then we have our LLM. We specified it here, GPT 4.1, as said. And then we have the agent type we can choose on. So here I've used chat zero shot react description. Okay, so basically this stands for the following. So basically chat stands for, okay, it's optimized for conversations. Zero means, okay, it works without any training examples. And then React is basically a system that the agent should apply. Okay, and this stands for, well, like RE stands for reasoning. Okay, and then ACT stands for acting pattern. Okay, and basically this gives, so to speak, a system prompt, yeah, that tells the LLM that the agent should think through this problem step by step first and then take the actions. Okay, and then description basically you should use the tool description to understand what each tool does. Okay, good. This is then basically how let's say wrong tool calls should be handled. Okay, and then verbose, we put it on to you know, to basically see what's happening under the hood, right? Okay, so I think the most important one here is with like kind of like this React. Okay, so that it's like a thought, action, and then observation kind of like loop that's kind of like going on. Okay, so let's initialize that, and now here we have our question. Tom M. Mitchell is an American computer scientist and the Founders University professor at Carnegie Mellon University. What book he write? What book did he write? Yeah. So this is our query. This is the question that we are trying to answer using Wikipedia, basically. Okay. So we're going to create this as an, you know, object and then put it into our function agent, and then we are going to take a look at the result. Okay, under the hood, because verbose statement is on. Now we can see, okay, here's the question that we've put in. What book did he write? And then we can see the thought that these chat zero shot react description basically has generated. And so basically the LLM, you know, tells us, I need to find out which book Tom M. Mitchell wrote. Searching for his notable works or publications will help. Then the action that it takes, because we gave it the tool Wikipedia, it takes the Wikipedia tool, and then the action input is Tom M. Mitchell. Okay, now something interesting happens basically. So the observation is the tool, through this tool, the LLM is able to find a page with Tom M. Mitchell. Okay. And then the summary is as follows. Tom M. Mitchell, born 9 of August, is an American computer scientist and the Founders University professor at Carnegie Mellon. He is a founder and former chair of machine learning department. Mitchell is known for his contributions to machine learning, artificial intelligence, etc., etc. He's a member of the United States Academy is also a fellow member of this and that. Okay, good. And then he was appointed kind of like as a dean. And then it looks also at another page, ensemble learning. Okay, in statistical machine learning, ensemble methods use multiple learning methods, algorithms to obtain better predictive information. Okay, and then basically it reasons over it and then says, okay, I know the answer. And then the final answer is then, okay, Tom and Mitchell wrote the textbook machine learning, right? Yeah, so this is this is one example where you basically you give it one tool that the agent kind of like can call. Yeah, another tool could be also web query, but basically what I have here is like a Python agent, right? Because we've seen that and I demonstrated to you yesterday that basically you can give the LLM the power to create code, right? And yesterday, and maybe Andrea, you also watched the video. I tried to just through chatting with the LLM to create a script that scrapes information from a website, right? And it did okay, right? It was able to scrape 3 out of 50 pages in like maybe 5 minutes or so. And then it ran into some issues, but basically we've seen that, okay, this LLM model is able to not only create the the Python script, but also kind of like I mean almost run it, right? So they've built a system that still the human needs to click on please run the code, but it could potentially also run it automatically. Okay, now here we do use something similar. So we have important the create Python agent, and this is basically a specialized agent factory designed specifically for Python code tasks. Okay, okay, it stands for REPL stands for read, evaluate, basically print and loop. Okay, and basically it's a Python interpreter that the agent can run. So the agent can run the code, can execute it, see the results, and it can iterate a little bit. Okay, good. Now let's see. So we initialize the agent, and now we give it a customer list with basically with names, Harrison Chase, Langchain, Dolly 2, L11. So just basically a customer list names, right? Random names. And now we call the agent that has access to this tool, and we basically tell the agent, okay, sort these customers by last name and then first name and print the output. Okay, something that we would need to do in an Excel spreadsheet or something, I don't know, code out by ourselves. Now we see whether our agent can do this. Okay, now if we run it, okay, it's entering the new agent execute a chain. It takes the action. Okay, I need to sort the list of customers by last name and then by first name and then print the result. The action input is the customer list and that we basically gave to it. Now here it basically looks into, okay, how would we sort? What would be the Python comment basically to sort the customers, right? And it would be this comment here. And then this would be the printed comment that the Python interpreter would need to run to be able to then show the sorted customer list, right? And so the observation is then, right? So the observation is then I need to sort the list of customers by last name and then by first name and print the results. Is not a valid. If there's not a valid tool, try one of Python repo action input. I need to sort. Okay, so it's basically repeating itself a little bit. Okay, continues. Okay, then it wasn't able to do it. That's strange. Okay, that's interesting. Before I ran it, it did work. So let us maybe try a different model. That's interesting. Wasn't able to do it. Okay, let's see. So it went through a loop and then wasn't able to do it. Interesting. Okay, now it did work. Okay, I don't know why for some reason. Now I used a different model, but I mean, I think it's a great, still great example, right? So you see, it wasn't able to do it. Now this time, I mean, it changed the model slightly. To sort the list of customer by last name, I will use Python sorting capabilities. I will write a function to sort the list, and then now it takes the action. Python REPL input is now the Python code. The customer, then the sorted customer, function to sort it, and then it prints it out. Now the observation is this reshuffled list. Okay, so now it's sorted after the first name first, and then by the last name. That's so then the last name comes basically here, kind of like first here. So AJ, Chain, Chase, Alan, Former, Fusion, and 2. So I did that correctly. Now it says I know the final answer. Now it gives us the final answer down here after it finished the chain. Okay, was interesting, right? So wasn't able to do it, didn't like troubleshoot somehow, but yeah, I mean, you can see like how under the hood these IDEs that that I showed you yesterday, how they are dealing with that. So probably if one model doesn't work, then you maybe use a different model that runs over it once again, and then is able to kind of like repeat the task, and then now here it was basically able to sort it out, right? Yeah. Okay, and then basically this is just to show you basically if we then are interested to learn how much tokens we used up by this, basically we can also get this out of the model. Okay. If we put the Langchain debug mode to true, like if you put this to true, then you are able to see not like, I mean, verbose is under the hood, but debug gives you also information on kind of like token size, etc., and some additional information. Okay, now that's interesting, but I think what's also potentially maybe even more interesting is that you can define your own tools. Okay, so you can design your own tools that you like the agent to be able to execute. So let's try to design a tool here. Basically, it should be a tool that we give to the agent that should allow the agent to do the following, to basically to return today's date, and use this for any questions related to knowing today's date. And the input should always be an empty string, and this function will always return today's date. Any date mathematics should occur outside of this function. Okay, so let's see. The way, so we're installing datetime to be able, so basically that the system is able to read, basically to call my computer system and look out basically the time. In order to create our own tools, we need to create from Langchain agents, we need to import the tool library. Okay, and once we import that, then by basically writing, add tool, we can then define functions, in which we can write into what basically action our LLM model should take. Okay, so it's actually fairly easy to basically set it up. So we give it like like a system prompt, okay, and then we specify the return, and the returns should definitely be also including or returning a string, output with basically the today's date. Okay, if we run that, if we create the tool and then we initialize the agent, so we give it the tools, and next to the tools, we give it this new tool, the time tool that we've created right in here. And we can go ahead and then ask the agent the question, okay, what's the date? What's the date today? We can ask the LLM. Usually it wouldn't know it because it's not able to access our, let's say, internal system properties with respect to the date. But because we've imported basically, you know, the date today, method in here, now it can call it, okay, and it should be able to answer this question. And so let's see under the hood what's happening. The thought is, okay, I need to use the time tool to find out today's time, action item time. And then the observation is, okay, today's date is June 6th. So now the final answer, today's date is June 6th, and now we finished the chain. So basically it did work, right? So we can print our result, and then what's the date today? Today's date is June 6th, 2025. And so basically this is how people build out their tools, and some tool, and sometimes some tools become companies, right? Like Perplexity AI, right? Maybe was the first one to be able to, or one of the first companies that was able to. So basically, they built the function that it can access the web, okay, and then you can basically, instead of doing a Google search, you can do a Perplexity AI search, and then ask the LLM about the most recent information out there, right? But this is, I think, again, very powerful, very customizable, and I think something that, this will be probably, in a few years from now, will be kind of like standard things that engineers, will be doing.